All right, as we move into 3.2, parallel lines with transversals, one thing to note is that everything we are dealing with here has parallel lines involved. So all of these rules and all of these definitions that we're going to learn about today have to do with parallel lines. If the lines are not parallel, then these specific theorems are not true. We cannot state the things we're about to learn if they are not parallel. So first we must note that since these are parallel, we're going to give them the notation that they're parallel, some sort of arrow or marking on both lines that show that they are parallel. We learned previously what alternate interior angles were. They are angles that are within the interior space, so the inside space here. It's a little big. Inside space in between our lines. But with parallel lines, they have a special power. Alternate interior angles are going to be congruent. So those alternate interior angles we are going to find are 4 and 6. So we can say angle 4 is congruent to angle 6. And then we are also going to have angle 3 and angle 5. So angle 3 is congruent to angle 5. So anytime we have parallel lines and we see alternate interior angles, we will know that those alternate interior angles are always going to be congruent to each other. Moving on, we have alternate exterior angles, and previously we learned that exterior angles happen in the outside space between my lines. And again, we need to mark that these are parallel, so I'm going to say, here we go. We've got our parallel line markings. And when two lines are parallel, alternate exterior angles are also congruent. So let's identify those. So if I have angle 1, that is going to be congruent on the exterior opposite side, angle 7. And then we can say we also can use angle 2 and angle 8. So angle 2 is going to be congruent to angle 8. All right, let's move on to corresponding angles. I like corresponding angles because they are all about shifting. They're in the same position but on one line to the other. So first, of course, we are going to mark that these are parallel because it tells me they are so. And corresponding angles, for example, if we want to remember, angle 1 is corresponding to angle 5. Angle 2 corresponds to angle 6. Angle 4 corresponds to angle 8. And angle 3 corresponds to angle 7. Now the relationship with these is that corresponding angles are also congruent. If you guessed that ahead of time, good job. There's a lot of congruent information provided. So angle 1 is congruent to angle 5. Angle 2 is congruent to angle 6. Angle 4 is congruent to angle 8. And angle 3 is going to be congruent to angle 7. All right, so we will move on to our same side interior angles. And we did also sometimes call these consecutive. So consecutive angles, if you see that mentioned, that is the same thing as same side interior angles. If you think about going in a consecutive order, it's things that are next to each other. So again, we're going to be dealing with the interior since these are inside interior angles. So we're dealing with this space inside. We're going to mark our lines as parallel. And the angles we're going to be dealing with are 4 and 5. They're on the same side of my transversal. But they are on the inside of my parallel lines. We're going to be dealing with those, and then we're also going to be dealing with 3 and 6. So the same side interior angles theorem tells me that same side interior angles are supplementary. So by definition of supplementary angles, We know a lot about that. We can say that angle 4 and angle 5 are supplementary. And we know we can eventually lead that into the path of the measure of angle 4 plus the measure of angle 5 equals 180. Eventually. We have to go through a few steps first. And we can say that angle 3 and angle 6 are supplementary. So again, after using the definition of supplementary angles, we can say the measure of angle 3 plus the measure of angle 6 equals 180.